Okay, today's lecture we will continue more on and do more examples in S-domain circuits. How to solve the circuits analysis using S-domain, no matter is it transient or is it steady state, is it DC or AC, it doesn't matter to us. Now, S-domain circuits, basically we need to convert every element into phasor or into S-domain. Before doing this, we need to calculate the initial condition. The initial conditions most likely can be determined if there is a switch. Then after that, we need to try to model everything, model the switch, model the other elements. So, let's write like today is March 20, Wednesday. The readings are page 131 to 134. And also, it's the due date for homework number 10 and homework number 11. So homework number 10 or number 11, there is no submission. So basically the solutions are posted also online in Canvas. Then next lecture, the 22nd, Friday, there will be exam too. I encourage you to go to the announcements. You can see like I wrote some details about the exam. And also there is a folder in Canvas, it's called Exam 2. That folder includes 3 files, 3 PDF files. The first PDF file, it will include the tables, table 3.1, 3.2, and table I think 4.1. These 3 tables are important and this will be provided to you. So this is a copy of what you will see for the exam. Then you don't need to write anything written in that 3 tables in your note sheet. You are allowed to have a 3x5 note sheet or note card. So use that size for something else, not for the information that you have in the table. Okay? Then also you will see a sample test. That sample test is basically, it can be an exam, like you can test yourself. It can be, the same level, difficulty level, the same question pattern. So it just, you can say as all the exams, something like that. Then basically what you need to do is try to discuss everything. Study the lecture notes, study the homework problems. Then when you're done, test yourself with that test exam. So don't look at it now, don't look at the answers. Test yourself, print it or whatever you want to do it and try to answer it. Then after that, look at the answers, then grade yourself. Okay, so I think it's very important for you to test yourself to have a look at this. But this does not mean the test will be the same as the sample test. Just pay attention to that. It's just like how the test will look like by looking at that sample test. Then in next week, the 25th, we will start chapter 5, which is basically a Fourier analysis, a Fourier series. Okay, so the deadline for asking questions about the exam is by tomorrow at 4 p.m. After that, if you have any questions, most likely I will not be able to answer unless like the next business day. So up to 4 p.m. So don't expect to send email until 11 p.m. to answer. But make sure the deadline after 4 p.m. So this is the table 4.1. We already explained this last lecture. And again, this one will be provided to you the test. So basically, this is the circuit. The passive elements are LC in time domain to S domain. So we see the inductor has 2 forms. The resistor will remain as is. The inductor has 2 forms. There is with voltage source or with current source. And why there are 2 forms? Because of the initial condition. If the initial condition based on the current or is the initial condition based on the voltage supply. So whatever you want to use, then we can use it. Either way, we need to know the initial condition of the current flowing the inductor. But If you like to use the series, then use voltage source. If you like to use the parallel, use the current source. So that's it. Capacitor. Also, it is also there are two models, depending again on the what you want. If you want a series or parallel, and there is initial condition. So both situations, if the initial conditions are 0, then model A and model B will be the same. Okay? If the initial conditions are zeros, then just those will be the same. Last lecture we started this example. So we said that we have this element and we have a switch. So we need to find I of t. I of t is located in the corner here. So how to calculate I of t? So the first condition or the first analysis, we need to assume or we need to find the initial conditions. Some problems, the initial condition can be provided. If they are provided, then you can skip step 1. But here, like the initial condition, no information about it, then we need to calculate. How to calculate this? Something similar to what we learned from circuit analysis and transient, which is when t less than 0, then the initial switch status was closed and it will be open at t equals 0. This is DC problem, so in DC circuits, before the switching action, everything was at steady state. This means any inductor will be short circuit, any capacitor will be open circuit. Or in other words, you can say 1 over SC or SL, and which is S here in DC, S equals 0. In DC, the frequency is 0, and S equals 0, that was in DC. Therefore, 1 over 0 will be infinity, then the capacitor is open circuit, while the inductor SL, which means 0 times L, which makes it 0, which means this is short circuit. Then after redrawing the circuit, what we need to do is to calculate the initial conditions for voltage capacitor, current of the inductor. That's what we do. Then how to calculate this? We can find the current by doing the KVL. It's like the KVL at the outer loop. When we do the KVL at the outer loop, we did calculate this. We already found this last lecture. Then how to find VC of 0 or the voltage of the capacitor terminals. Basically doing KVL loop 2, then we can calculate this. So now, so far, we calculated the initial condition, step number 1 done. Step number 2, let's do the conversion from time domain to S domain. How to do this conversion? Let's look at the original circuits. The switch, or at t larger than 0, which means the switch will be at the new position, or the new switch status. The new switch status, it will be open. Okay? Then what will happen to the remaining parts when it is open, like what we have here? What will happen to the inductor, or I think this resistor and the voltage source? It's outside of the circuits. Okay? Then this is not related. I didn't need to take it into consideration. That's why I neglected it. I cross it. I'm gonna neglect this because it's outside. It looks like someone is sitting outside of this classroom. I don't care what's going on outside, right? I'm caring what's happening here. Then the same thing here. This does not mean it's short circuit or it's open circuit or something like that, or it's being shorted or eliminated. It's not eliminated, but I mean, I don't care about it, so I'm gonna remove it. I'm not, which is again, like, don't care. I don't care about what's going on. So that we will end up having this circuit in time domain. So I'm still here, time domain. Which is, we have a capacitor, resistor, inductor, and voltage source. So the voltage source, keep in mind here, we said when t larger than 0, that's why I put 20 u of t, because I inserted u of t because it is at t larger than 0. Okay? Then what should I do? We need to convert this circuit, which is step number 2, convert this from time domain to phasor domain. But keep in mind, in order to do that, make sure you are applying the final switch status, make sure you already know the initial condition. So the initial condition of the voltage of the capacitor, it was, I think, 18 volts. The initial condition of the inductor currents, it was negative 1 amperes. Now I'm ready to do my conversion. So the voltage source, let's start with the source, 20 u of t. So 20 u of t, it will be as 20 over s, right? That's the voltage source. And it will remain as is. Then the other thing, which is the inductor, I'm going to go as counterclockwise. So the inductor. So the inductor that we have is 1 over 3 Henry with current IL of 0 negative equal to negative 1. So I need to convert this into S domain. To convert this to S domain, it will be, I have two options to use, either the series or the parallel. So I like the series. So since it's single loop, so I can keep it single loop. While if I use a current source, it will be parallel. Then most likely I like to make it easier by making a single loop. So I would like to use the series, which is current source and inductor. So this is SL. This is according to the table. It is L IL of 0 negative. Okay. Now let's substitute the values. SL. L is 1/3, so it will be S over 3. Then L times IL of 0, which means 1 over 3 times IL of 0 negative 1. Okay? So it will be negative 1 over 3. Okay, do you agree with me with this? So far so good. Let's start with the other elements, then go to the next elements. Here again, I'm over-explaining it, but maybe you don't need to do over-explaining like this. You can draw the circuits and do it with everything else. But here I'm over-explaining this just to let you know what is going on. While for the next example, I'm not going to do this. I'm going to make it faster. So for the resistor, 2 ohms, it will remain as is, 2 ohms, no change. Then the last thing, which is the capacitor. The capacitor, it is, what was the capacitor's value? 3 over 8, yes. 3 over 8, and the initial condition, VC of 0 negative equals to 80. So again, I like the series formula. So in series, it will be this capacitor with the current voltage source. That voltage source is actually VC of 0 negative divided by S, and this one is 1 over S. Now let's substitute the values. A C is 3 over 8, therefore 1 over 3 over 8 will be 8 over 3, so it will be 8 over 3S. Then what will happen to the source? Vs is equal 18 over S. Okay? Now I did the conversion for all of the elements. We have 4 elements, 1, 2, 3, 4. Then I'm ready to redraw this. Again, when you do the problems, you don't need to justify this. You can redraw this new circuit and write the values on it. So it will be like starting with the capacitor. So there's a source here, plus minus 18 over S. Then here is, this is the capacitor, which is 8 over 3S. Then we have the resistor, 2 ohms, as is. Then we have the inductor, which is inductor, and the voltage source. So that inductor is S over 3. This voltage source is negative 1 over 3. Then we have plus minus 20 over S. This is the voltage source. After that, keep in mind we need to calculate the currents, the overall currents. So we will no longer say I of t, it is I of s. That's what we need to do. How to calculate I of s? Do KVL, right? Let's do KVL movement. Start from the left bottom corner, then travel clockwise. So 18 over s plus, this is an impedance. Impedance, which means I. So I times 8 over 3s. Plus, there's 2 ohms, so I times 2. Plus I times S over 3. Then a source negative 1 over 3. Plus 20 over S. Equals to 0. Okay? Is this clear? Now, we need to calculate I. So let's isolate everything and make I, put I in the other side. So basically, I can say it is I 8 over 3s plus 2 plus s over 3 equals, moved it to the other side, 18 over s plus 1 over 3 minus 20 over s. Okay. Then we need to calculate I, so I will say that I of s equals to be, we can do actually simplification, 18 minus 20. This will make it as 2 over s plus 1/3, just for information. Then I of s will be 2 over s plus 1/3 divided by Braggs long term, which is 8 over 3s plus 2 plus s over 3. Then we need to remove the s from every element, so basically look at the common factor 3s. Then what I'm going to do, I'm going to multiply by 3s here, 3s here. So this yields I of s to be 2 times 3, 6, s will go. 3s times 1 over 3, 3 and 3 go, so plus s, 6 plus s. Then divided by, here, I think there is a negative sign there.
I think the 1/3 should be.
1/3 should be negative, and here this should be negative, so there should be 2 negative. Negative. So it will be negative 6 minus 6. Then 8 times 3s, 3s will go, so 8 plus 2 times 3s, 2 times 3 will be 6s, plus 3s times s, so 3 and 3 can go together, it will be s squared. So as a shortcut since we prefer to write it in the polynomial way as negative s minus 6 over s squared plus 6s plus 8. Now, this is I of s. Our target is to find I of t. So, what should I do? Do the partial fraction expansion, right? So before doing this, is this strictly proper? Yes, it's strictly proper. So it is strictly proper. So let's do partial fraction expansion. Before doing partial fraction expansion, let's try to find the roots of this one. So this one is actually, after making simplification, it is s plus 2 times s plus 4. Keep in mind, if in case it's not strictly proper, what you need to do is do the long division. Then now I'm ready to do the partial fraction expansion. So this will be as c1 over s plus 2 plus c2 over s plus 4. So we need to find the c's. So to find c1, it is s plus 2 times I of s, substitute when s equal to negative 2. This means negative s minus 6 divided by s plus 4. All of them when s equal to negative 2, so the answer will be negative 2. C2 will be s plus 4 times I of s, substitute when s equal to negative 4. This means negative s negative 6 over s plus 2. All of it substitute when s equal to negative 2, so the answer will be 1. Since we know the c's, go back, substitute them. I of s will be negative 2 over s plus 2 plus 1 over s plus 4. I'm not done yet. We need to convert this to time domain. So let's do the Laplace inverse. Laplace inverse I of t equals to Laplace inverse of I of s. Then it's going to be as negative 2, 1 over s plus 3 plus 2 means equal negative 2t u of t, using the tables. And we've done this a lot, so I think we did it a lot, so we know memorize this because we already done this many times. Then here, s1 over s plus 4 equal e or negative 4t u of t. And don't forget to write the unit, which is amperes. Then that's it. Problem done. So we solved this circuit without worrying about the complexity of the differential equations or without worrying about what we've learned before in the transient, while we can do it in quantum. And again, this is applied on DC, we can do it in AC. But most likely, if we do it in AC, we might get more complicated with sinusoidal group form. But we can still handle it. Just do the partial fraction expansion with the conjugates, and it should be fine. Okay, let me do more examples so we can be professional on it. So the more you practice, the easier it will be. So here is a problem. So assume we have this voltage source, a switch will be on at t equals 0, a resistor 2 ohms, inductor 1 Henry, capacitor 0.5 farad, then V input is given as E or negative T. Now it's no longer DC, it's AC. So what we need to do is we need to calculate the voltage here. We call it V volt. According to our procedure, the first step is what? Do the initial condition, right? So let's do the initial condition. When t less than 0, when t is than 0, the circuit will look like this. So what will happen to the current of the inductor and the voltage of the capacitor? What do you think the current of the inductor would be? 0, because it's open circuit. So IL of 0 negative equal to 0. How about the capacitor? The capacitor voltage equal to C di of t by dt. And since it is current is 0, then it will be 0. Okay? Then problem 1 done. Step number 2, we need to convert this into S domain. But we have a switch. How can we get rid of the switch? The switch and that source will be as U of t, right? So it will be e power negative t U of t. So I'm going to modify on the time domain here on the circuits. It will be as e power negative t U of t volts. Then here I just remove the switch. We have 2 ohms. We have this one 1 Henry. Then 0.5 farad. Then we have here the plus minus V of t that we need to do the calculation. And we know the initial condition IL of 0 negative equals 0 and VC of 0 negative equals 0. Then now I'm ready to do the conversion. Let's do the conversion. I can do it in fast way. I don't need to over-explain it like what I explained before. I can do it faster. So we will say that the source, it is e power negative t U of t. E power negative t U of t is 1 over S plus 1, right? 1 over S plus 1. Then the resistor will remain as is, 2 ohms. The inductor will be what? I can use the series form, which is here, source and the source, minus plus 1, right? So we will say that this is SL, L is 1, S, so it will be S. And this one will be L times current source, which is L times 0, or 1 times 0. This means it will be 0, right? So this one can be neglected, because it's 0. What will happen to the capacitor? It will be a capacitance here, and there is a source. So that capacitance, it is 1 over SC, which is 1 over 0.5S. So 0.5 is 1 up, which is, in other words, 2 over S. How about this source, which is, this will be S over, this will be 1 over, or no, VC of 0, which is 0 over S. In other words, it will be 0. This mean can be neglected as well. Or in other words, you can say, since the initial conditions are neglected, I don't need to worry about the sources. So whatever more convenient for you. So then I'm going to redraw the circuit again by removing these zero elements. So it will look like very similar to the phasor building. 1 over S plus 1, 2 ohms, S, and this one 2 over S. Our target is to calculate the voltage. How to calculate the voltage? It's a circuit analysis. We need to calculate the voltage and this capacitor. Okay, do you know how to calculate it? There is one way. You do KVL, right? Then find the currents. Then you can say VO is I times Z, right? Or Einstein times Peterson. Is this correct? That's one way. Another way, do you know what's the other way? Have you ever heard of voltage division? So whatever more convenient for you, you can find the current or you can use voltage division. Let me use voltage division, because I like it. Then we can say this is as V source. Then we can say VO of T equal V source. I'm sorry, S. VO is equal to V source of S times the impedance of the capacitor over the impedance of the capacitor plus impedance of the inductor plus impedance of the resistor. In other words, you can substitute the values. V source, which is 1 over S plus 2, plus 1, times Z out, ZC, which is 2 over S, divided by 2 plus S plus 2 over S. So we have S here. Let's multiply both sides by S. Both terms are denominator and numerator by S. So this is to be 1 over S plus 1 divided by times 2 over 2S plus S squared plus 2. In other words, we can say that, again, this is VO of S. This is VO of S. We can say VO of S will be 2 divided by S squared plus 2S plus 1 times S plus 1. How can we solve it? We need to do the Laplace inverse. To do the Laplace inverse, we can use partial fraction expansion. So let's find the roots of S2, S squared plus 2S plus 1. So we realize that
why did you remove the plus 2?
Yeah, plus 2. Okay, I forgot. So thank you. Plus 2. Okay, so S squared plus 2S plus 2 equal to 0. Let's find the roots. To find the roots, basically, we can say this is S equal to minus B, which is minus 2 over 2A, 2 times 1, plus minus square root of B squared, which is 2 squared, minus 4AC, which is 4 times 1, times 2. Then it will be as negative 2 over 1, which will make it negative 1, plus or minus square root of 2 squared 4, 4 minus 8 will be negative 4, divided by 2. This will make it negative 1 plus minus 2 square root of negative 1 divided by 2. 2 and 2 cancel each other. Minus 1 plus minus square root of negative 1. Square root of negative 1 is what? J. Then it will be as negative 1 plus or minus J. This is S. As a result, we can say VO of S will be 2 divided by S plus 1 plus J times S plus 1 minus J times S plus 1. So how to do the partial fraction expansion? C1, C2, C3. And keep in mind C1 and C3 will be conjugated. C1, C2 will be conjugated. So basically it will be C1 over S plus 1 plus J plus C2 over S plus 1 minus J, then plus C3 over S plus 1. Again, keep in mind C1 must equal to S2, C2 conjugate because S1 or this is associated with two complex conjugates. Then how to calculate C1? C1 equal to S plus 1 plus J times VO of S, substitute when S equal to negative 1 and negative J. Then after doing substitution it will be 2 divided by negative J times S plus 1 minus J. Then when S equal to negative 1 minus 1 minus J. So S plus 1 plus J will be 2 over S plus 1. Substitute is equal to negative 1 negative J. So the answer will be negative 1. Then to find C2, we can say it's either C1 conjugates, and since there is no imaginary part, it will be the same as negative 1, or you can calculate it. C2 will be S plus 1 minus J times V of S, substitute when S equal to negative 1 plus J. Then it will be 2 over S plus 1 times S plus 1 plus J, substitute when S equal to negative 1 plus J. So the answer will be negative 1. Then the last thing, which is to find C3. C3 will be S plus 1 times V of S when S equal to negative 1, which is going to be 2 over S plus 1 plus J, S plus 1 minus J, substitute when S equal to negative 1. So the answer, I think, will be 2. Let me substitute this. Then, as a result, VO of S will be 2, let me see what will be negative 1 over S plus 1 plus J minus 1 over S plus 1 minus J plus 2 over S plus 1. That's VO of S. Then, in order to calculate VO of T, so VO of T will be the Laplace inverse of VO of S, which is the Laplace inverse of this expressions. It is going to be as negative equal minus 1 minus J T U of T minus equal negative 1 plus J all over times T U of T. Then what else? We can say plus 2 equal negative T U of T. So now you should stop here. The answer will be done here. And of course the unit is false. This is correct. But sometimes in some textbook or some others you might see sine or cosine, you might see something different than the expression. How can we get it? So we're going to do further simplification for your information, or maybe later if you're at the lab or if you are doing some other courses. How can this expression be simplified more? I mean, for the purpose of the homeworks, this is enough, or the exam, this is enough. But I'm going to simplify it more in case if you're going to need it in the future, and even like for information to see how is the sine or cosine will be added. So I can simplify it more as V of T equals 2 e power negative T U of T. Then I'm going to put a negative sign as a factor, then negative and make it U of T as well as a factor. Then it will be e power negative 1 e power negative 1 e power negative J T negative 1 T J T, just multiply by T both sides, minus, or here it will be positive, plus a power negative T 1 T a power positive J T. Okay? You agree with me on this? Just take some factors and try to isolate the product for the explanation. So we see that e power T is a common factor. Let's put it outside of the bracket. So here it will be 2 e power negative T U of T minus U of T e power negative T. So what remains inside the brackets? E power negative JT plus e power jt. Okay, what should I do later next? Multiply 2 by 2 both sides. Okay, so what? We will say 2 e power negative t u of t minus 2 u of t e power negative t. Then here this is the first two, I'm getting different colors. Then e power negative jt plus e power jt divided by 2. That's what I did. And according to Euler's formula, this is what? Sine or cosine. We call cosine theta e power j theta plus e power negative j theta divided by 2. Okay? So this is cosine, cosine t. Then it will be 2 e power negative 2 u of t minus 2 u of t e power negative t, then times what? Cosine t. Okay? Again, I still simplify more. I can simplify more. So because we have here 2 e power negative 2t, t power negative t u of t. So I'm going to take it as a factor. So the answer will be 1 minus cosine t 2, or even I can say it like this one, 2 u of t equal to 3 volts. This is u of t. Okay? This is the simplest form. So you see here, the first one that we box it's based on exponential forms, but when you see sometimes the answers is based on cosine. How we can get this? By simplifying it more, by just doing more math. So again, for this course, I don't want to make it too complicated and you to make it the simplest formula, but keep this in mind. So if you can do it, do it. But you will not get extra credit for that. I mean, just for your information, and also it will be useful for you in the future when you go for future courses. You are going to use these kind of formulas always. Any question? So the circuits here, you see, it's cumulative. We're using what we've learned from signals, what we've learned from Laplace transformation, from circuits, all of them in one. This is the complexity of this part. And when we did the first example, the complexity was the convolution and the integration associated with this. Now the complexity here and doing some math. But I like this. I think this is easier than the convolution. That's what I like. Or even this worse than the convolution. Any more questions? Let's do one more example. Assume we have this circuit. So this is the resistor, capacitor, this is R2, this is R1, this is I of t, this is AC, and here's I. And our target is to calculate plus minus V out of t. Let me give the values, so I'll assume this one as 1 delta of t amperes. Okay, so this one, I cannot use the previous circuit techniques because we have delta of t. So the circuit techniques that we've learned before in circuit analysis, I cannot use them. It's a small challenge. Then the resistor here, 1 ohm. The capacitor, it's not realistic, I'm going to assume 1 farad. Then back to 1 farad. By the way, it's unrealistic. In real life, there is no way to find the capacitor 1 farad big. The capacitor of the whole way might be 1 farad. For this problem, I'm going to assume the initial condition provided. Okay? So when the initial conditions are provided, you then need to calculate it. Vc of 0 negative equal 1 volts. IL of 0 negative equal 1 ampere. Now, this saves one step, okay? If assuming the initial conditions are not provided, you need to calculate, is there a switch? No, therefore assume them as zeros. But most likely, if there's no switch, I will give you the initial condition, or I will tell you assume them as zeros. So don't worry about it. So again, with this statement, when the initial conditions are provided, this you can save one step. Since the initial conditions are known, all of these elements are written in signal analysis, so I can do the Laplace inverse. I'm sorry, the assumed Laplace transformation. So let's start with the current source. The current source will be as I of s, right? What's the I of s? What's the Laplace transformation of delta? It is the number itself, which is 1, right? It's 1. Then, the resistor will remain as is, right? No change in the resistor has to be. So this is 1 ohm, that 1 ohm. What else? The capacitor, I have two ways. I can use the parallel or the series. So in this circuit, I prefer to use the parallel since the capacitor and the resistor are in parallel. I like to use the parallel form. So here's the parallel form. This is 1 over SC. This is C, VC of 0. Okay? Now the capacitor is, capacitance is C, so it will be 1 over S. Then C, VC of 0 negative, this means VC of 0 negative is 1. Then it will be C is 1, so the answer to this one will be 1 ampere. Okay? What else? The R2 resistor will remain as is, which is 1 ohm. Then the inductor, you have two ways to use the series or the parallel. I'm going to use the parallel. Here is LS, then the parallel. This will be as IL of 0 negative over S. So LS, since L is 1, this will be S, IL of 0 negative, which is 1 over S. Now, remember that the voltage of the capacitor here, and of the inductor here, VL. Okay? How can we solve the circuit to find VL of t? We can do nodal analysis. Nodal analysis, assume this is as node 0. And assume this node, which is the voltage of the capacitor, VC of S. And the other node, this is on VL, which is the same as this one. And here is node under of T. Okay? So the node voltage VL, then we have VC and 0, right? I don't need to call them V1, V2, I'm going to call them as VL, VC. Whatever you want, you can call them V1, V2. So how to do the nodal analysis? Our target is to calculate VL of 0. So we have multiple unknowns. In order to do this, let's do like the nodal analysis. I'm gonna do KCL and node VCS. To do the KVL, basically the sum of leading currents. That's my assumption. The sum of leading currents equals 0. So let's start from the node at the green node. We have this current is entering negative. This current will be V over R, this is V over Z, this is entering, which is negative. So this yields to be negative I source plus VC of S minus 0, which is VC of S, divided by R1 plus the other one, VC of S, divided by the impedance, which is 1 over SC. Then the other one, this current source is entering, then we put negative sign. So it will be as negative C VC of 0 negative. What's the else? We still have that branch, which is 2 ohms resistor. How to calculate it? VC minus VL divided by the impedance. This is not a limit. Are you all aware of the limit, right? You know? So then plus VC of S minus VL of S divided by the impedance between them, which is R2. No other elements, so this will equal to 0. Now I need to try to simplify it more by taking VC as a common factor. So this will yield to be 1 over R1 plus U1 over R2 plus 1 of SC will be U plus SC times VC of S, then minus 1 over R2 times VL of S. Then I'm going to move the constants to the other side, this constant, and this constant was VC of 0, I of S. So this will be I of S plus C VC of 0. After that, I'm ready to substitute the values, which is going to be, this is 1 over 1 plus 1 over 1 plus S times VC of S minus 1 over 1 VL of S equals to be I of S, which is 1, VC of 0 equals to 1. I substitute the values. Then this yields to be 2 plus S VC of S minus VL of S equal to 2. Now we have two unknowns, equation of two unknowns. So I'm going to say this is equation number 1. We have VL of S, VC of S. Again, according to nodal analysis, we will need to do node at each node, do KCL except the reference is 0. So we have 3 nodes. Remove the reference, we have then 2 remaining nodes. So we need to do KCL at the other node, which is VL of S. So KCL at VL of S. How to do it, which is basically the sum of leading currents equals 0. Then substitute the values. This will be VS, VL of S minus VC of S divided by R2 plus VL of S over LS plus IL of 0 negative divided by S equal to 0. Then I can simplify it more by making the process of 1 over R2 VC of S minus 1 over R2 plus 1 over SL, all of the VL of S equal IL of 0 negative over S. Now I can substitute the values 1 over R2, which is 1 over 1, VC of S minus 1 over 1 plus 1 over S, VL of S equal to 1 over S. So as a result, this yields to be VC of S minus 1 plus 1 over S times VL of S equals 1 over S. Let's multiply both terms by S, here by S and this by S. Multiplying them by S. This yields to be also by S. This yields the equation to be S, VC of S minus S plus 1 VL of S equal to 1. So this is the second equation, 2 unknowns. So in summary, let's solve the equations. Equation number 1, it was S plus 2 VC of S minus VL of S equal to 2. Equation number 2, it was S VC of S minus S plus 1 times VL of S equal to 1. 2 equations, 2 unknowns, we need to solve them. How to solve them? We can basically say S plus 1 times equation number 1 minus equation number 2. Then, after doing this simplification, we can get VC of S to be as 2S plus 1 divided by S squared plus 3S plus 2 minus S. Or in other words, we can say VC of S equal to 2S plus 1 divided by S squared plus 2S plus 2. Okay, I know that I'm running out of time. If you need to leave the classroom, you can leave. But I need to finish this example. You can go to the recording in case if you want to do that. Now we need to find V out. So you can substitute this into equation number 1. It's just math, here one. So there's 2S plus 1 times S plus 2 divided by S squared plus 2S plus 2 minus VL of S equal to 2. As a result, VL of S will be 2S squared plus 5S plus 2 minus 2S squared plus 2S plus 2 divided by S squared plus 2S plus 2. It's not. The last thing, VL of S will be S minus 2 divided by S squared plus 2S plus 2. Then we can do the partial fraction expansion to calculate this. So it's going to be as S minus 2 divided by S plus 1 S plus J plus 1 S plus 1 plus J. Then here S plus 1 minus J. Then to solve this we need to have 3 C's. C1 over S plus 1 plus C2 over S plus 1 plus J plus C3 over S plus 1 minus J. Then when we calculate C, C1 will be S plus 1 times V of S. When S equal to negative 1, this will be 1. Then when you calculate SC2, it will be S plus 1 plus J V of S. When S equal to negative 1, negative J, this will be negative 3. Then C3 will be S plus 1 minus J times V of S. When S equal to negative 1 plus J, this will be another negative 3. So VL of S will be C1, which is 1 over S plus 1, then minus 3 over S plus 1, plus J minus 3 over S minus 1 minus J. Then we do the Laplace inverse for that V of t, VL of t will be e power negative t U of t minus 3 equal negative 1 minus equal negative 1 negative gt U of t, then minus 3 equal negative 1 that was t U of t. And that's what we need to start about. Even we can continue more to convert this to the sine or the cosine function. Okay. Any question? Sorry for taking this apart.